Hello crypto family, welcome back to my channel. Today I'm going to be making a two-part series. The first part consisting of Polkadot primer, and then second part consisting of why I like Polkadot, what are some of the risks associated with Polkadot, how is it different from some of the other blockchain, and also do a evaluation exercise. Now why I want to do a Polkadot primer is that I have a belief that it should be not amongst top 10 blockchains in terms of market cap, but in fact it should be amongst top 5 if not 3. So for that reason, I believe there's a lot of misconception, and I think even now a lot of people don't understand what the severity of what Polkadot is trying to achieve. So maybe this primer will help, and it also allows me to kind of check my knowledge if I understand the blockchain architecture well. So Polkadot is a layer 0 solution, and you'll be wondering what the hell is layer 0. So in order for me to make you understand that, it's to give you a brief understanding of what a layer 1 blockchain is. So layer 1 blockchains such as Solana and Ethereum, they have other protocols built on top of its network, and those protocols are basically leveraging the security and decentralization of that network. So what layer 0 tries to do is it tries to go one step ahead, and instead of just having protocols built on top of it, it wants to connect all the layer 1 blockchain in its entirety. So layer 1 provides you security. Layer 2 is the protocol built on top of that, and layer 0 is basically a meta protocol which connects all the layer 1 blockchain. And this is one of the ways to understand what Polkadot is doing. So Polkadot is trying to do multiple things, but the foremost and the most important application of Polkadot is that it seeks to be a multi-chain platform that incorporates interoperability and allows for scalability. And that happens because it's a layer 0 solution. So now if you look at the existing blockchains, they are typically acting in silos. For example, without any bridge, it's impossible to transfer information from, let's say, Bitcoin's blockchain to Ethereum's blockchain. So Polkadot, as a layer 0 solution, as a meta protocol, as a protocol of protocols, seeks to connect all the blockchains so they can process information, data, and assets are transferred in parallel. So in other words, it aims to be a protocol of protocol, a layer 0 solution connecting all the layer 1 blockchain and their application. So let's say if you're talking about Bitcoin and Ethereum, the application would be the transfer of ERC20 tokens in some form. And this idea is also known as consensus enforcer. So if you look at the chart over here, when I say interoperability, that means all the layer 1 that are built on top of Polkadot can communicate with each other. And these interoperability layer 1 could be Ethereum, BTC, or could be other layer 1 that are initiated, recently introduced. I'll discuss more about it also in the following slides. Polkadot also have certain future-proof attributes. One of the attributes is the on-chain governance. So like individual stakeholders, like in Ethereum or even Bitcoin, they're powerless when it comes to proposing or vetoing a particular protocol change, unless they know the right people. So how the governance works is, let's say if something happens within Ethereum and they want to do something about it, the community gathers around Twitter, Reddit, but there is no on-chain governance. And I think this is one of the aspects that Cardano also wants to bring, but Polkadot also has this feature. The on-chain governance is not just simple. They're also bringing in certain intricacies, which will make, in my opinion, governance much more smoother and much more prominent. The individual stakeholders within Polkadot can also help elect Polkadot Council, and this can be done by representatives or the stakeholders which are passive within the Polkadot governance system. So let's say if they have few dot and they don't think they can make a difference, what they can do is they can elect the right Polkadot council. Now, Polkadot Council is also very unique. So Polkadot holders can propose certain changes or veto a protocol change, but Polkadot Council can also do that. So both the Polkadot holders and the Polkadot Council both have this power. Polkadot Council also has the ability to elect the technical committee. So technical committee is one of those committees that say if there's an emergency within the network and requires certain changes on an immediate basis, they will be able to do so and will be able to act swiftly, and that's because and they're elected by the Polkadot Council. Polkadot Council is also on a lookout for any malicious proposals, and they can also propose changes and things like that. So if you look at the governance structure, is beautiful. Now, even in terms of the voting, they have gone one step ahead. So normally you would expect that one token equal to one vote, but that's not the case in case of Polkadot. Uh, the network utilizes a very unique system. It's called a conviction multiplier, where those holders that are able to stake up their tokens for a longer period of time can receive more dots. So if they are able to lock their dot for longer, the intensity of the vote, the power of their vote increases, and you can kind of see the chart over here. So let's say if you lock it for 180 days, you will have 6 times, your vote will have 6 times more power. Another novelty of Polkadot network is that is of forkless upgrade. So there will be no hard forks to upgrade its network. This is because of a combination of automated node updates and on-chain governance. Now, this is quite opposite to blockchains like Bitcoin and Ethereum, where we have seen Bitcoin splintered into Bitcoin Cash and other hard forks, and Ethereum into Ethereum Classic. And this happens because when we are in a position of a fork, it requires users to actively coordinate and execute a protocol design. So the nodes that fail to upgrade basically gets booted off the network, and that's why you have a hard fork. So their approach is that there will be no node left behind, and this will prevent Polkadot from unexpectedly splintering. And it makes sense because it will be very disastrous for the whole network and all the layer 1 that will be built on Polkadot if there's a hard fork, and it will be very difficult for them to manage the consensus, because what they're actually doing is they're just renting out the security from Polkadot. So this is also one of the novel features of Polkadot, which differentiates them from other blockchains. So within a Polkadot ecosystem, a developer firstly does not have to care about the security, since when a developer, he or she gets into the Polkadot ecosystem, they're kind of renting out the security, which I'll go deeper later via relay chain. But not only that, let's say a developer wants to create its own layer 1 blockchain. What Polkadot provides is a framework called Substrate, and this framework for coders is extremely customizable. So what do I mean? The coder just has to focus on the business logic in order to construct a new blockchain on Polkadot, and the customizability enables the developer to optimize their chain for a particular vertical. So you can see from the diagram over here, a developer can focus on an NFT parachain. Parachain in this case, just think of it as like a layer 1 blockchain. So they can focus on NFT vertical, or they can focus on gaming vertical, or privacy token, or a stable coin, or DeFi, or maybe a governance token parachain, or a blockchain, or perhaps a bridge. So when they're focusing on the business logic, Polkadot will provide you a kit that will allow you to customize it based on a particular vertical you're targeting. Not only that, Polkadot chain also adapts to the needs of developer in other ways as well. So Substrate, in terms of my knowledge, also has an Ethereum virtual machine module, where even though the substrate base language is Rust, the EVM module opens the door for developer to perhaps port the Ethereum Solidity contract to Polkadot blockchain. I think this component was built with the help of Moonbeam. So you can think of it like in music equalizer, yeah? Substrate can allow coders to drag and drop certain blockchain consensus mechanism, and like an equalizer with dials to turn up or down certain features. So basically a developer can also become a DJ where they just have to focus on the business logic of the blockchain and also kind of um, outsource some of the development work because the substrate is such a compact and useful framework. And I will have confidence on substrate since it's developed by Mr. Gavin Wood himself, who created the Solidity programming language. And he was the one who also orchestrated the EVM, Ethereum Virtual Machine. So I'm very confident, and he was also the CTO of Ethereum. So I'm very confident that he will be able to pull this off, this framework. So this customizability also allows kind of like a network effect where other developers can quickly jump in and does not have a steep learning curve for them to kind of become the part of the ecosystem. So in terms of Polkadot, Polkadot has a very unique cross-chain interoperability. It also has a very unique on-chain governance, and it's also highly customizable. So how are they able to achieve all of this? So in order for you to understand that, I'll just show you this through a diagram and then delve deeper into each component. Uh, so Polkadot unites a network of heterogeneous blockchain shards. This shard is similar to Ethereum, but slight difference. When I say heterogeneous blockchain, I'm just in a fancy way saying individual blockchains. Unique individual blockchains are connected together and also can do cross-chain communication via relay chain. So this part over here is the relay chain. So as you can see over here, this is the relay chain. So this the security and the cross-chain communication is done via relay chain. Then these parachains, which are individual sovereign blockchains that have their own tokens, which are optimized for their own functionality for specific use case. It could be NFT, DeFi, Web 3.0, Oracle, whatever. And these parachains are also connected to relay chains. And these parachains can have two models. One model is that they lease out the security for, let's say, 2 years, or maybe they don't want it for 2 years. They only want it for a few months. So in that case, instead of having a parachain, there will be a para thread. So para thread will be like 5-6 different projects or blockchains built on one parachain, and each of them are just slotting a position. So we do understand that parachains are plugged into a network known as the relay chain. So relay chain in essence is the central hub or the heart of the Polkadot ecosystem. It manages Polkadot validators and coordinates security for active parachains. So on purpose, you can think of relay chains being deliberately simplistic compared to parachains. So one thing for sure, it doesn't support application development, and it should not be confused with smart contract platform of deployment. Instead, it serves three purposes, which I'm going to go deeper into. First one is the security. So the relay chain manages all the validators within the Polkadot proof of stake system. If somebody is staking dot, they're actually staking the dot on the relay chain. Polkadot validators help secure and process transactions for both the core layer and active parachains. Parachains are basically, and I've repeated this again and again, are essentially renting the security provided by these validators and stakers. So parachains won't need to bootstrap a validator set and have enough economic security to dissuade a 51% attack. Instead, they'll each receive a share of the security provided by the relay chain. So relay chain is providing a shared security system model for all the parachains within the ecosystem of Polkadot. Secondly, you have interoperability. The relay chain will also be the central communication layer for all the parachains. It will act and route and validate all the information and messages passed between parachains in exchange for fees. So the whole system can also be thought of as internet service providers who deliver internet access to users. So in this case, the relay chain acts as ISP and parachain supports the end user application. And finally, you have the on-chain governance system. So the relay chain houses the Polkadot's on-chain governance system. All Polkadot's proposal and network changes are approved by dot holders get processed on the relay chain. While each parachain can have their own independent governance system, the decision carried on by the core governance layer at layer 0, and that impacts all the connected chains, happens here. So bifurcating um, storage and computational requirement away from the relay chain into parachain. So for example, in Ethereum, you must store every smart contract and network interaction in perpetuity. But Polkadot's relay chain will only store and process snippets of information it receives from Parachain, while Parachains handle the majority of user activity. So what it does is the relay chain becomes relatively storage efficient, and the design is such that it increases and allows the Parachain slot to even go beyond 100 and without having any significant performance degradation. So we can kind of see that the design itself can also enhance scalability, since there isn't a lot of storage and computation requirement on the core layer, which is the relay chain itself. So now moving to parachains. So there will be 100 plus different parachains that will be connected and plugged into the relay chain, and they mostly fall into two broad categories. The first one is the layer 1 chains, which are basically these slots are actually acquired through an auction process, which I'll discuss later. The auction process consists of a crowd loan, which is an alternative to ICO. And these parachains usually will have their own tokens, and each one gets to produce a block for every relay chain. So they'll collect all the information and then send the information to relay chain. Then you have a common goods chain. Now these chain, in my opinion, will typically consist of bridges to existing parachains. So common goods can be kind of thought as a positive externality to the whole network. So they will be usually be awarded to those. They will be awarded through a governance vote, but they'll only be awarded to those projects which will be helpful to the whole Polkadot ecosystem. So, for example, in my opinion, a bridge to perhaps a bridge to Bitcoin, Solana, or maybe Ethereum, which helps bring more users, more liquidity, and bootstrap the network, could be one positive externality, and that could be a common good chain. And certain parachains are slotted for these type of chains. So I mentioned in my previous slide that parachain would be auction. So one question that generically comes to the mind is, why would a project want to pay for a parachain? Now, I've mentioned these 2 points in snippets, even in my earlier slides, but there are two key reasons. First, you have instant economic security. So the project, when they get the parachain, they do not need to spend the time, money, or effort trying to establish a validator set and then build up enough economic security to make 51% attack prohibitive. Instead, what they can do is they can outsource their security needs to relay chain and focus on creating the business model they want the end users to have. So this allows the developer to just focus on what they're good at and doesn't require large amount of upfront capital to kind of secure the network. Now the other thing is interoperability. So parachains will be able to communicate and transfer information and even assets with 100 plus blockchains develop within the ecosystem, and those 100 plus blockchain will have application stacks on top of them as well. And then you also have bridges through other networks like Solana, Bitcoin, Ethereum, and relay chain will act as an information router. So you have this cross-chain compatibility, which is also attractive to a lot of developers who just wants to focus on things they're good at, which is coding and developing the project. So in order for a project to become a parachain, the project has to post DOT as a collateral to kind of make a bid to secure a parachain slot for 6 months to 2 years. So this bid is done through a candle auction, which I'll explain in a later slide. But this bid and this collateral of DOT can come from project's own treasury. It could be a private investors backing them, or through a unique mechanism where the DOT is loaned from the community. So the community can loan them the DOT, and in exchange return the native token of the project. So this crowd loan system is alternative to an ICO, and these delegated dots will be locked in the Polkadot relay chain and will never be touched by the parachain. And in fact, when the lease period lapses for the parachain, it will be returned back to the community. So now let me just go over the candle auction bid. So in terms of a candle auction, there are some game theoretic elements to it, which makes this auction kind of a success. So let me just explain how the auction works. So let's say you have a period of 2 weeks, and let's say the day one starts and the auction ends at at the 14th day. Your community can let's say your token B, the community can give you 43, they can loan you out 43 dots, for example. Over here you have KSM, but let's assume it's dot. So 43,000 KSM. But after a few days, your community loans you out 22 more dot and increases the bid. Now, the issue is, if you have a normal auction process, what happens is, let's say at the end of 13th day or 14th day, everybody starts to bid more, and it becomes I'll say problematic for the bidder, because then you don't have a fair allocation. So what candle auction does is, okay, you have a start date and you have an end date, and in the middle of that start and end time period, a randomly allocated time is selected, and whoever has the highest bid during that time wins. So it kind of incentivizes bidders to basically push in as much as a dot possible during the auction period, rather than there is a race to the end. So whoever pushes more dot in the end wins. So that's not the case. So in terms of game theory, this kind of auction makes sense, and this is what Polkadot uh, is using. So the demand side of tokenomics looks very good. First, you have bonding. So let's say if a project they want to secure a parachain, they have to commit dots, and there will be demand for Polkadot year on year, even though those dots will be returned back. But if somebody wants a position within the parachain, they will have to commit dot and lease it. So that's the bonding part. Then there is a staking part where validators stake dot for a chance to be nominated to generate a new block on the relay chain. And since it's a proof of stake, there is an incentive for good behavior, as dishonest validators will have their stack slashed. So I'll also have to introduce the concept of nominators here in Polkadot ecosystem. So people who want to stake, they actually select the validators on the network that they would like to contribute their dot towards, and they can select up to 16 validators. Apart from that, another usage is of transaction fees. So dot is also paid to transfer data or send information to the relay chain, and this can, I think, apparently can also be done in the native token of the parachain. And then final use case of dot token is for governance. So you get the on-chain voting, and that voting could be very important going forward, since you'll have network upgrades, you have changes to network fees, auction rules, perhaps if they want to alter, if the community wants to alter the rule for parachain and other proposal. And we already saw a vote being passed on in the 86 percentage of favor, where the dot was rebased from 10 million dots to 1 billion dots. So that was one interesting governance use case. So demand side seems decent, and you have different use cases. And I typically like to avoid coins but just have governance feature. But in this case, you have three other features, which is bonding, staking, and for transaction fees. So who are so based on the tokenomics, the demand side of the tokenomics, who will be the natural buyers of the dot? So firstly, you have the team that wants the parachain. So they will either commit enough dots or ask the community to delegate their dots. So those are the one stakeholders that will be the buyers of dot. Uh, the other one will be the parachain itself. They will have to either accumulate enough dots to pay transaction fees to send data, or perhaps take some part in the governance. So the parachains will also accumulate dot over time, maybe through their treasury. Then you have fishermen who will stake their dot to monitor the behavior of validators and collators, and since they are rewarded if they identify misinformation, so these fishermen will also be staking dot. So that's also another stakeholder that will be buying dot. And those people who wants to take part on the on-chain governance, so they will also need dot with them. So in terms of the supply side tokenomics, firstly, Polkadot currently has no cap on the actual supply. Foremost and more importantly, we do not have, like initially how the Polkadot was distributed to private, like in private sales and some of the investors. So we don't know who has the most amount of dot with them, because they also did private sales during 2016 to 2018 period. So that for me is also slightly problematic. Apart from that, I also believe the inflation rate which is available to validators and stakers, which contribute resources to network security, is also high. And this inflation is also not static. It is going to be quite dynamic, and the new issuance will be given to validators based on how much actual amount of dot is staked within the network. So for example, if the actual amount stake deviates from the target value, either above or below, the proportion of rewards dedicated to validators will change depending on that, to incentivize users to take stake. Uh, and also, if the new issuance that doesn't go to validators will eventually end up in the treasury. So yeah, they also have like a token bund. So if 1% of any treasury fund that is not spent during its 24 hours budget period will be burned, and also any amount staked in relation to the rejected governance proposal will also be burned. So let's say if you wanted to propose something, and that proposal was rejected by the community, some of the amounts will be burned. So the amount you have to have in order to push a proposal, that particular amount will be burned. So it has some good qualities, like burning mechanism. I think it's good to reduce the supply, but it also has few issues. Firstly, no cap on the supply, high inflation, and plus we don't know how the private sale issuance meant how much the crypto whales have, and how they can unload on some of us uh, retail retail client. There are hundreds of projects that are being built on a Polkadot ecosystem, and it can be subdivided into different categories. So if I just scroll through, you can like see uh, how many in different capacity, as like a wallet, or as for tooling, substrate based, infrastructure based, are being built. So in my second video, I will select few of the potential parachains that will get listed on Polkadot, and some of their sister projects have already been listed on Kusama, and try to analyze them so we can like find next 20-30 bagger from the ecosystem. So that's the task for the part 2 of the video. But along with this, I'll also try to value Polkadot, and also discuss a bit about Kusama, whether Kusama could be a nice proxy. This one, Moonbeam, is one of the projects I really like. I think the investment thesis for Moonbeam is quite simple. You can leverage both the growth of the Ethereum and Polkadot ecosystem simultaneously, since it deploys Ethereum compatible smart contract on Polkadot and provides the EVM compatibility. Thanks for watching, guys. I hope you enjoyed the video. Since it's a new channel, I would really appreciate if you smash that like button. It really helps with the YouTube algo. And I will also like you to subscribe to my channel, so you can also get the update when I publish the next video. The next video will be a part of Polkadot series, where I'll conduct the evaluation and see how Polkadot compares with other layer 1 and layer 0 solutions, and what are some of the risks associated with Polkadot. So yeah, thank you for watching. And also don't forget, if you want to have access to some of my exclusive content, and to see my own altcoin portfolio allocation, you can become a part of my Patreon journey, where I share some of these things with my community. Thank you.